Now in this class we will discuss the double integral over the bounded region. Over the bounded region. Bounded thing you can abbreviate as BDT. Okay. So how can we define it? Let f of xy be a bounded function defined in a region defined over a region E. So what is the region? The region is like this: A comma B, and phi of x is less than or equal to y is less than or equal to psi of x. So here, as like the previous thing, the first pair is limits of x. So limit of x are constant, but limits of y are functions of x. So if in the integral you find that the integral limits of the integrals are function of x, then you think that the limit integration will be with respect to y. If it is the functions are function of y, then the integration will be with respect to x. So here limit of y are functions and limit of x are the constant. Then the double so here what will happen I will tell you later. First I will write the double integral, then I will write. Then the double integral then the double integral over E is given as given as double integration over E f of x comma y dx dy is equal to, here integration a to b is are the limits of x, and integration I will write y equal to phi x lower limit and y equal to psi x will be the upper limit f of xy dy and then dx. So here we don't have the luxury that any one of them we can put as inner integral and other one as outer integral. If we get the limit of y as a function of x, then we have to write y as in inner integral and x as in the outer integral. That means the variable with the limit integral limit is constant will be outer integral, and the variable with the limit as function will be the inner integral. Since here I am having the limits of y are function of x, so the inner integral will be with respect to y. If I have the limit of x with respect limits of x are the function of y, then I will keep x as the inner integral. So in this case, how can I say is, suppose this is my xy plane, x and y plane. Okay, so here x equal to a and x equal to b. Suppose I will, what is the lower limit of y? Lower limit of y equal to phi x. So suppose this is my curve y equal to phi x, and the upper limit is nothing but y equal to psi x. So suppose this is my curve y equal to psi of x. Okay, so y means bottom to top, y means this direction, x means this direction, either positive or negative direction, but this will be the thing. Y means from bottom to top, x means from left to right. So here I have the limit of this. Similarly, x equal to a, x equal to a means this is my x equal to a. x equal to b means this is my x equal to b. So this is the region bounded by x equal to a, x equal to b, and y equal to phi x, and y equal to psi x. So we have to evaluate the double integral in this region. Okay, so when you are taking the limit, y will be from the lower to top in this direction, and x will be from left to right. So whenever you are coming across this type of integration, remember that you have to sketch the graph. You have to sketch the graph because with the help of this, we can able to change the limits also. We can put y as outer and x as inner if you draw the figure. But remember one thing, we cannot take randomly the order. If the limits of y are function of x, then y will be the inner integral, and if the limit of x are function of y, then x will be the inner integral. Okay, so here I will give another thing. The similar way I can give, I can make a note here. If the region E is such that a b, and here I will have phi of y is less than or equal to x is less than or equal to psi of y. If this is my region, then I cannot say a and b are limit of x, because here x limit I know that they are function of y. So in this case, I can say the double integral over e f of xy dx dy as integration a to b, and then inner integral is with respect to x because the limit of x are function of y. So I will write x is from phi of y to psi of y, and fxy fxy dx, x will be inner integral and y will be outer integral. So this is the basic difference between the double integral over the bounded over the rectangle and the double integral over the region. In this case, how can which region we are going to find the double integral? So here, suppose this is my y and this is my x. So y equal to a means this is my y equal to a, and y equal to b means this is my y equal to b, and x equal to phi y, that will be the lower limit. So it is the thing, this is nothing but x equal to phi y, and this is the thing, sorry, this is the curve, this will be nothing but x equal to psi of y. Now this is the region bounded by these four things: y equal to a, y equal to b, x equal to phi y, and x equal to psi y. So here we have to evaluate the double integral. Remember, x will be inner integral here because the limit of x are functions of y. So x will be inner integral, and the limit of y are constant. So we will consider y as the outer integral. So the variable with constant limit will be always outer integral. The variable with function as a limit will be always inner integral. So let me take some example here. Example is evaluate evaluate double integration over e x square plus y square dx dy over the domain bounded by y equal to x square and y equal to x. Okay, so this is the y equal to y square equal to x. So this is your question. Here we don't know what are the limits of x, what are the limits of y. Only thing we know that y equal to x square and y square equal to x. You know that these are the two parabolas. So in order to determine the limits of x and y, we will construct the parabolas. We will construct the parabola. So how can we construct? So first of all, we will construct the parabola in this way. This is my x-axis and this is my y-axis. So y equal x square equal to 4ay. What is the how the parabola looks like? It is symmetric about whatever value of x and y it is symmetric about y-axis. Symmetric about y-axis. That means it will be upward. So we can have like this. This is my curve x square equal to y. 4a is nothing but 1 here. Similarly, y square equal to 4ax. It is symmetric about x-axis because you take y both positive and negative, x is always positive. So it will be in the positive x-axis side. Okay. So y square equal, it looks like open towards right. And so since here in place of 4a I am having 1, so I can have like this. So this is the thing y square equal to x and this is the thing x square equal to y. So this is my region. This is my region. So at least one thing we know here. What is the thing we know? Here we can say x as inner integral, y as outer integral, or we can say y as inner integral, x as outer integral, and accordingly we have to put the limit. So what I want to say here is I will write this one as integration. My function fxy is x square plus y square, and suppose I want to put y as the inner integral and x is the outer integral. As I have told you, if you are taking the variable outside outer as the outer integral, it should have constant limit. So what will be the constant? At least you know the point here is 0 comma 0, and the point here will be the solution of these two things because these two curves are intersecting here. So can you able to get the solution there? What is the solution you will get here? You see y equal to x square. So you solve them. y equal to x square. But from here y square equal to x. So from here what will you get? What will you get? Y equal to y square whole square. That means y to the power 4 minus y equal to 0, and so y will be common. Y cube minus 1 is equal to 0. So y may be 0 or y may be 1. Y may be 1. Okay. So if I put y equal to 0, if I put y equal to 0, x will be nothing but 0. If I put y equal to 1, x will be nothing but 1. This is my x and this is my x. So this point definitely represent 1 comma 1 because x0 y0 is giving this value and a y1 x1 will give you this value. So this thing as I put y with respect to y as inner integral, x as outer integral. So the limit of x must be constant. So what will be the limit of x? Limit of x is starting from 0 and going up to 1. So I will put here the limit of x is 0 comma 1. And then y means from the bottom to top. From the bottom to top. So this is my y range, limit of y. So what is the down limit? What is the lower limit of y means down curve, the curve which is below. So what is the limit of y? Y is equal to x square. So y equal to x square. And what is the upper limit? Limit of y, don't write x, y square equal to x. Here you have to write y in terms of x. So y will be nothing but root x plus or minus root x, but it is positive quadrant, so we will take only positive root x. Now our aim is to evaluate this. Our aim is to evaluate this integral. Okay. So now how can we evaluate it? So once again I am writing this one neatly. Integration 0 to 1, and the inner integral is integration y is from x square, y is from x square to y equal to root x, and here it is x square plus y square. Since the limits are functions of x, I will integrate with respect to y first, then I will integrate with respect to x. So here you can integrate the inner part first. Inner part in x square with respect to y is x square y, and y square with respect to y is y cube by 3. Now I will put the limit, lower limit of y is x square, upper limit of y is root x. Okay, and then wherever y is there, I will replace the upper limit as well as lower limit, and we can evaluate it. So integration over 0 to 1, and this one will be y in y is root x, upper limit first you put y equal to root x, so root x means half, so this will be x square into root x square into root x means x square into x to the power half, so x square plus 1 by 2, that is x to the power 5 by 2, x to the power 5 by 2. Now I will put here yq. Yq is there, so x equal to root x, that means x to the power 1 by 2 to the power 3, that means x to the power 3 by 2. So the upper limit give you x to the power 3 by 2 divided by 3, minus what will be the lower limit? Lower limit is x square, wherever y is there you put x square, so x square into x square is x to the power 4, and here x square to the power 3 means x to the power 6, so x to the power 6 by 3. Okay, so this is the integral which we need to integrate with respect to x. Now I will apply this, I will integrate it with respect to x. Integration of x to the power 5, x to the integration of x to the power 5 by 2 dx is nothing but x to the power 5 by 2 plus 1 divided by 5 by 2 plus 1. So this will be nothing but 7 by 2, 7 by 2. So I can have x to the power 7 by 2 divided by 7 by 2 plus, similarly this one 1 by 3 is constant, x to the power 5 by 2 divided by 5 by 2, and minus integration of x to the power 4 is x to the power 5 by 5, and this one will be plus integration of x to the power 6 is x to the power 7, 3 into 7, and then you put the upper limit and lower limit. Upper limit is 1, lower limit is 0, so if you put x equal to 0, everything will be 0, so only upper limit we need to put here. What are the upper limits? So this one will be 2 by 7, x to the power 7 by 2 is 1 to the power 7 by 2 is 1, and here it will be plus 2 by 15 minus here 1 by 5 plus 1 by 21. Okay, so if you simplify this, what we will get? Let me simplify like this. I will take these two things first. So 2 by 7 minus 1 by 21 plus 2 by 15 minus 1 by 5. So what we will get? LCM is 21. 6 minus 1. 6 minus 1 is 5. 5 by 21 plus LCM is 15. So 2 2 minus 3 is minus 1. So we will have minus 1 by 15. Now you can find the LCM and you can simplify it. So we will get it. This will be equal to, if we simplify it, we will get it 6 by 35. You get it 6 by 35. This will be your answer. So if somebody want that, suppose x will be the x will be the inner integral, y will be the outer integral, then the limit of x should be function of y and limit of y should be constant. So that thing you can write here. You can write here this or you can evaluate this one. This is the integration and x you can write and then y. So the outer integral always have constant limit. So y value from the graph is y is from, you see, y here is 0, y here is 1. So y is from bottom to top, y value is bottom to top, that is 0 to 1 only. And so y limit will be 0 to 1. Now x limit, you see left to right, left to right. That means you have to take in this direction, in this direction. Left to right means the left part is y square equal to x. So you can have here x equal to y square and you can have here x equal to root y. And you can evaluate it, the same answer it will get. But when you are changing the thing, you have to take care of the limit appropriately, otherwise you will get wrong answer. Next, another example I want to solve here. Evaluate double integration over e x square by y square dx dy. E is bounded by, where e is bounded by x equal to 2, y equal to x, and xy equal to 1. So this is the thing given. Now in order to evaluate this one over the region E, we need to find the limit of x and y. So how can we get the limit of x, y and y? If we draw the region, then only we can able to find the limits of x and y. So how can we draw the region? So this is the xy plane, x, and this is my y. Now x equal to 2. First I will draw the graph y equal to x. Y equal to x is the graph this. Y equal to x. Now xy equal to 1. Xy equal to 1 is the rectangular hyperbola which is drawn as like this. So this is nothing but xy equal to 1. This is nothing but xy equal to 1. And x equal to 2. X equal to 2 will be nothing but x equal to 2. Okay. So which is the region bounded by all these three curves? So this is the region bounded by, so this is the region. This is the region bounded by these three things. Bounded by the three curves. X equal to 2, x equal to 2, y equal to x, xy equal to 1. So this double integral I want to write like this: x square, y square, and something I want to put inside and something I want to put outside. Okay, so let me put y inside and then x outside. Remember, here I am always saying it is not only the way. You can put x inside and y outside, and accordingly you can find the limit. So here I will put y inside and x outside, and accordingly I will find the limit. Okay, so x is outer integral, x should have the constant limit. So what is the value of this? Here I am having xy equal to, here I am having xy equal to 1, here I am having xy equal to 1 and y equal to x. So y equal to x is here. So that means this coordinate will be 1 comma 1. And here x equal to 2 already known, but y equal to x. So x is 2 means y will be also 2. So here I have 2 comma 2. Here I have 1 comma 1. So suppose y is x is outside, means my limit of x will be from left to right. My limit of x will be from left to right. Left to right means the left hand minimum value of x is 1 and maximum value of x is 2. So the limit of x will be 0 to 2. Okay. Then inner integral should have the function of x, because inner integral is with respect to y. The limit of y should be function of x. So how can we find function of x? I will start from bottom to top. Y is from bottom to top. So what is the lower bottom of y? Lower limit of y. The lower limit of y starts from xy equal to 1. So here we will have xy equal to 1 means I will have xy equal to 1. So I will have y equal to 1 by x. So I can write here y equal to 1 by x. And what is the upper limit of y? Upper limit of the y is y equal to x. And so I can have here y equal to x. So after that, I can evaluate this integral. After that, we can evaluate this integral. So what will be the evaluation of this integral? This will be integration 0 to 2, and then x is constant with respect to y, so you can take it out, and the remaining thing here I will put y equal to 1 by x and y equal to x dy by y square, and then I will integrate with respect to x. I will integrate it with respect to x. Now in the previous problem I did how to integrate 1 by y square or 1 by x square. So this integration will give you x square will be as it is. Integration of this one will be minus 1 by y, and the limit is 1 by x to x dx. Now you can again integrate it with respect to this. We put the limits. So minus will be outside x square, and upper limit is nothing but x, so 1 by x. Lower limit is nothing but 1 by x, so minus 1 by 1 by x and dx. Finally you can write this one as integration 0 to 2, so x square into 1 by x minus x dx. So multiply x square with both the expression, what you will get? Integration 0 to 2, this one will be x, so minus is there already, so this one will be x cube minus x and dx. Minus I multiplied, so it is like this. And so integration of this one is x to the power 4 minus x square by 2, and the limit is 0 to 2. So lower limit is 0. So if I put x equal to 0, everything will be 0. So only upper limit we will put 2 to the power 4 by 4 minus 2 to the power 2 by 2. So this is equal to 4 minus 1, 4 minus 2, and this is nothing but 2. This is nothing but 2. Okay. So like this we can evaluate the double integral. We can evaluate the double integral over the bounded region. I will take another example. To take another example, evaluate 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 double integration over e y dx dy over the part of the plane over the part of the plane over the part of the plane bounded by the lines the line y equal to x and the parabola y equal to 4x minus x square. So here itself we know that y has limit x and 4x minus x square. So y is function of x. So I can say this is my phi x and this is my psi x. So here I have to keep y as inner integral and x as outer integral. But y limit we know it. But what is the limit of x? We will try to find out from the graph. So now let me sketch the graph here first. Here one is y equal to x. So we don't have any problem for that graph. Now other one you see y equal to 4x minus x square. So I can make it perfect square y equal to minus of x square minus 4x. Okay. So what I will do, generally I know that y minus a is equal to 4 into x minus b. I can have like this expression. I can have like this expression to get the parabola type thing. So what I will do here, I will make it like this y equal to minus of x square minus 2 into 2 into x plus 2 square. So if I subtracted minus 4, I will add 2 square so that the value will remain same. Okay, so this is the thing, and we can have it here as minus of x minus 2 whole square plus 4, and here we can have y minus 4 equal to minus x minus 2 whole square. So here the focus is shifted to 2 comma 4. Okay, focus is shifted to 2 comma 4, but it is a parabola similar to y square, sorry, x square equal to 4ax, but the focus is at 2 comma 4, and this is, since negative is there, so x square equal to 4y will be like this, but since negative sign is there, we will have the opposite. It will open towards down. It will open towards down, and so we will sketch the graph like this. So this is the curve y equal to x. This is the curve y equal to x, and the focus at 2 comma 4 will be somewhere here. So the focus is shifted to there, and so we can have like this. It will be downward. Okay, now this is the point of intersection, this is the point of intersection. So this point, y equal to 0, x equal to 0 here. So 0 0. Now we have to find the little point at this thing. So this is intersection of two y equal to x and x equal to y. So we will put in this expression y equal to x. So y equal to x means what we will get here. What we will get here is x equal to 4x minus x square. And so 4 minus x equal to, so we can have here like this, what we will have, uh, x square minus 3x equal to 0, and so x into x minus 3 equal to 0, and finally we will get x equal to 0 and 3. So whenever x is 0, y will be 0. From the curve you see, whenever x is 0, y is 0 in both the curves. And whenever x is 3, what will be the value of y? X is 3 means y will be also 3, because it is y equal to x. So this point is nothing but 3 comma 3. So if you take y x outside, x is from starting here 0 and here going to 3. So the double integral we can write in this way. So double integral over e y dx dy will be nothing but integration. We will put y inside because we know the function limit of y as function of x. So limit of y, so here we will have y dy then dx. So limit of x, you see, limit of x means left to right. Here limit of x is 0, here limit of x is 3. So we can put here 0 to 3. Limit of y means we have to consider from bottom to top. Bottom is this line y equal to x, so you can have y equal to x. And top means the curve this one, so you find the limit as y equal to 4x minus x square. 4x minus x square. And now you evaluate it. So first you evaluate the inner integral. Inner integral will be y square by 2, and the limits are x to 4x minus x square. 4x minus x square, and then whatever answer you will get, integrate it with respect to x. And so integration 0 to 2, 1 by 2 is constant, you can take it out. Y square in place of y, 4x minus x, so 4x minus x square whole square is the upper limit, and the lower limit is x square, and you integrate with respect to x. Okay, now you open this one, 1 by 2 will be there. If you open the thing, this will be nothing but 16x square minus 8x cube plus x to the power 4 minus x square dx. Okay, so now 1 by 2 integration 0 to 2, 15x square minus 8x cube plus x4 dx. You integrate it one by one, what you will get, 1 by 2 is constant, and so I will put here, what is the integration of x? Sorry, this is 3, not 2. X is from 3, 0 to 3. So x is from 0 to 3. So now this one will be 15x cube by 3 minus 8x4 by 4 plus x to the power 5 by 5, and the limits are 0 to 3. So you can simplify it. Here you can 3 1 ja 3, 3 5 ja 15, 4 1 ja 4, 4 2 ja 8. And so what will be the thing here, you will get 1 by 2, 5 into x is nothing but 3, 3 to the power 3 minus 2 into 3 to the power 4 plus 3 to the power 5 by 5. You simplify it and you get the answer. So maximum degree or degree of 3 is minimum degree is 3. So I can take 3 to the power 3 common divided by 2. Remaining thing is 5 minus 6 plus 9 by 5 plus 9 by 5, and so that one will be 27 by 2, and this is 9 by 5 minus 1, and so 27 by 2 into 4 by 5. Finally what you will get? 2. So 54 by 5. This is your answer. This is your answer. Okay. So like this we can able to evaluate the double integral which is defined over the rectangle as well as the bounded region.